Okay, right now I want to explain how to come about your beam detailing in AutoCAD. Okay, as I was explaining from this drawing where we were able to pick this particular beam, I just used this rectangle to highlight this beam 6 which I'm trying to detail. You can see this is the first span 1230. The second span is 4 meters, so this is actually what I have here. If I measure this is what I'm going to have. This is the first span and this is the second span. Then I have my top bar here. I have the reinforcement at the bottom here. This is at the compression zone, this is at the tensile zone. Okay, I will ask you, I will encourage you to lay your hands on BS 8666. So you should lay your hands on BS 8666. You're going to see different bar shapes. They are codes, okay, and then there are formulas, okay, on how to know the extent that your bend is supposed to go, the distance that it should go, the minimum, okay, and then the maximum it can go. Okay, these are some of the things you're going to get from this BS 8666. Okay, this is British standard. Okay, 8666. Okay, so if you lay your hands on this, you're going to have more insight on how to on this bar, each bar's shapes and their codes, okay, and then the formulas behind all of that. And then so from that from the previous tutorial, which I was actually explaining how you can actually get this reinforcement based on the design that you must have done. So based on our design report, we are assuming that we are having a 2y16 bar here. Then here we are also having at the bottom here also another 2y16 bar. Okay, one thing you need to take note of is this, that let's say assuming this beam is actually the first beam we are designing. If this beam happens to be the first beam, this is most likely going to be 2y16, and then this bar mark here instead of 14 should be 01, because this is the first beam we are designing. And then if this reinforcement is going straight from here now to this place based on this design, okay, assuming the design is providing just one reinforcement that goes this way, we do not have a top support bar here, assuming in that case we are definitely not going to, we are going to be having just one bar, so it's just going to be 2y1601. okay, so it depends on the design. So if this reinforcement is going down and then this entire reinforcement to this end is actually just one, it's going to be 2y16, and then the mark here will be 02 instead of O. Here you go, going to be, okay, this is not going to even be 02, this is definitely going to be 01 if it is the same, except in a case whereby this reinforcement is actually y20, for example. Let's say this is y20, because this reinforcement is going to be different from this one, is different, but this based on the shape, based on the length, and then the size of the reinforcement. Okay, so that is how to know if you have the same type of reinforcement. So this is not the same type of reinforcement, this is y16, this is y20. You can see they have exactly the same shape, okay, and then the reinforcement is actually not the same. So that is why it's having a different name, O2. So in a case whereby this is actually carrying the same size of reinforcement, and then it has the same shape and is covering the same length, you can see the same length, the same shape, the same size of reinforcement. So in that case, this is going to change to O1. So that means this is O1, this is O1. So that is one thing you need to understand. And then here you can see where I was able to explain that this is my columns at those supports. You know, we have up to 3 different supports here. If you look at this, we have a support here, we have a support here, we also have another support here. So this is the first 2, 3. Okay, this is 1, 2, 3 exactly. So but then we need to capture the slab. You know, everything is actually casted monolithically together. Okay, so if that is correct, the slab thickness, let's see, for this design is 150 mm, based on what we have gotten from here. You can see this is slab thickness 150 mm. This is also 150 mm. So in a case whereby your slab thickness here is 150, the one here is also 150, so it's just going to come out straight, just like the way it's coming out straight here. But there are cases whereby you see your slab on one span is different from the slab on the other span. Just maybe by the time you run your analysis, you run your design, then it may tell you that the deflection is not okay for 150. You may want to increase the thickness of that slab. So by the time you increase the thickness of that slab based on your design, and then whichever thickness has actually passed based on the design that you must have done, all you need to do is just to specify that, and it's going to reflect here in the cross section here. So instead of having a 200 here, all you need to do is just to tap here. If I tap, so you can see here now, from here I'm having a 150, and then from here to here this is 150, from here to here is going to be 200. So I'm just giving you an instance, but in this design all the slab thickness is actually 150. Okay, so I'm not having any 200 here. So this is 150, it goes straight. But you know, like I said, this is casted monolithically. You can see the column here, because it's casted together. I have to actually trim these, so you can see I just trimmed that. Okay, well, I'm not supposed to have, yeah, exactly. So this is going to be in this way, and then here I'm going to have it this way. Here I'm going to have it this way. So this is how this is going to look like. So this thickness here is actually the thickness of my slab, which is 150, as you can see. Okay, so let's say we have a top support bar here, for example. I was able to explain all of that in the previous tutorial on this beam detailing. So let's say we have a top support bar here, and then you know this span here is actually at 4 meter span. All I need to do is just to take 1/4 of that 4 meters, which is going to be 1 meter. So if I type in 1 meter and then I offset it this way, which I was able to explain the last time. So from here now I'm going to have this reinforcement, then I will have another one that comes down below this to overlap with the one I have here. Okay, so okay, so to get this other shape, all I need to do, you can honestly, it makes your work a bit more faster by the time you copy from an existing drawing. Let me match property here. Let me just match this property with the one I have here. Okay, yeah, you can see this thickness has reduced a bit, which is makes my work much more better now. Alright, so here now, let's say I take this by 750. Let me take this by 200. Sorry. Just trim this. Alright. So this is actually going to overlap by, you can see this reinforcement only just bent this way. If you want to check for all your bends, your shape codes, okay, all you need to do is just to go through that BS8666. Sorry, let me correct this. Text edit BS, okay, so BS8666. If you go there, you are going to see how you can actually achieve each of your bending. It has formulas based on the kind of the bending you want to achieve. All these bend shape, they have their codes, okay, in different codes, okay. So all you need to do is just to lay your hands on BS8666, okay, to be able to understand all of that. If I really want to go through all those bending codes and all that, it's going to take a whole lot of time to really achieve all of that. And then you're overlapping at your tension zone, you're overlapping at your compression zone, okay. There are values for them, okay. For your tension is 40 times the diameter of the reinforcement. Then for your compression, I hope I'm right. For your tension should be 40 times the diameter of the reinforcement exactly. Then for the compression is actually 50 times the diameter of the reinforcement. Okay, now you know the reinforcement here that we used is actually Y16 for my top and then Y16 for this bottom here. All I need to do now is just to, if I offset this, I'm going to type in I'm going to type in that value because this is my compression zone, which is 50D. So I'll multiply 50 times the diameter of the reinforcement, which is going to give me 800. So all I need to do is just to type in 800 here to be able to know where this overlapping is going to end. So this will lap to this point, and then I can delete this. I can also delete this. Okay, so in that case now this reinforcement is now a separate reinforcement from this. So in that case, this reinforcement, let's say here I have let's say here I have 3Y16 for example. All I need to do is just to edit this and type this by 3Y16 from the design. For example, this one will definitely be true, and then this reinforcement will be number 3. Okay, so this is exactly how to come about your detailing in your beam. Okay, but like you know, all the informations I'm actually typing here is based on what I was able to get from my design. These are actually not assumed values. Okay, we're able to show you the design reports in the previous class on beam, how we're able to use the the design reports of a particular beam from Prota structure to explain the detailing from that particular report. And then it's the same thing here we are doing, just assuming we already have a design for this, and then we are designing or doing this detailing based on that particular design we are actually assuming right now. So we are just assuming values, assuming that we have a design report for this. And then let's say from that design report, this is 3y16. Definitely this mark will change. This is 1, this is going to be number 2, and then this is going to be our number 3. Okay, and then there is a case where you may have a lap at the bottom here. So in that case, you know, like I said, this is going to be 40 multiplied by the diameter of that reinforcement. Okay, all right. Then another thing, lest I forget, here now around where we are having our, okay, this reinforcement that bends here, like I said, you should lay your hands on BS 8666, where it says that the diameter of the reinforcement should be multiplied by 5. Okay, so 5 multiplied by 6 should either be equals to or greater than 5 times D. Okay, so if that is correct, if you multiply 16 multiplied by 5, we are going to be having around 80. 16 multiplied by 5, we are going to be having around 80. So it says it should either be equals to or greater than. Okay, so so if you measure this now, I was able to make it exactly 180. So but I can adjust this to this and then adjust this to this, because it says it should either be equals to or greater than 80. So if I measure this now, it's going to be greater than 80. Okay, this is also going to be greater than 80. So practically on site, you can do all of this calculation just to achieve a good result. Alright, I choose to leave it this way. Another thing you need to take note of is this. You need an allowance for this here. The allowance here, I'm going to be using 50 mm. So let me mirror this here, 50 mm for your links actually. Okay, because you are actually going to be having your links are definitely not going to start from this support inside your support, because here we are having a support which is a column. So your links will not start from inside that particular support. So here we are having 50 here, 50 mm. So this is it, and then all I need to do now is just to specify my links here. Measure this by sorry, I can just pick from an existing drawing here. So this, okay, let me bring this out. Right, so if I have this now, here this is stopping here, so my links is actually moving from here good. All right, so I'm also having another links from here. Oh, this thing, I'm supposed to have extended this to. All right, good. So this one will not be able to fit into this place. I can just use my text, edit, and probably take off everything here and just leave the 14 here. So here now, if I'm having a 200 spacing of my links, for example, this is going to be 6, which I explained last time. So this is going to be 6, 4. So that's 4,000. Okay. This is going to be 20, most likely, approximately. Okay, so here I have 20 Y10. If my link size, the size of my links is actually Y10. Okay, so whatever the design is asking you to use, or whatever you must have specified, if it passes, and then you can adopt that. If it is Y8, fine, but it's customary to use Y10 for your links in Nigeria here. All right, so that is that. So this is exactly how to come about your beam detailing in AutoCAD. It's very easy to actually come about. I was able to explain how you can achieve this. I was able to explain why this bend is this way from your BS8666. Okay, and then whichever kind of bend that you see is actually from your BS8666 code of practice. Okay, if you can lay your hands on it. All you do, you can go on Google, just search for it. You are going to see the tables and all that has to do with their formulas. Okay, they are very much available even online. If you go online, you can lay your hands on them. Okay, while there are books that covers that too as well. So but this now, since this is one single reinforcement, I can just place it here at the center, just to put it here. So this is the entire reinforcement that goes this way to this point. But there is also a case where you may actually have a reinforcement that may actually be breaking at the bottom here. So in that case, like even the entire length of your reinforcement is always 12 meters. Even it's not even always even up to that 12 meters now, around 11.5 meters. Okay, so if that is correct, by the time you measure it, you discover it's not even up to exactly that 12 meters. So by the time you measure, so there are cases where you may have a beam, a continuous beam that spans, it exceeds the entire length of that 12 meters. So definitely you are going to be having an overlap at the bottom there. So in a case where it requires you to overlap a reinforcement at the bottom here, like all you need to do is the same concept that we did here. All you need to do is just to use the same the same 50. Now it's going to be 50 instead of 40D. It's going to be 50 because this is our compression zone. Okay, so it's going to be 50 multiplied by the diameter of that reinforcement. So if the reinforcement is y20, for example, we are going to multiply 50 multiplied by 20. Okay, so whatever value you get there is what you're going to use to overlap there at the bottom here. Okay, but in this case we are having we said this is actually going to be y12. Sorry, this is y16, right? So because this is actually y16, all I need to do is just to overlap these. It depends from where you want to actually really want to even overlap from. So but that is actually the concept. But let me pick from this. Let me see, I have an existing drawing, or let me just overlap from the support here, around my support here. I'm going to offset this by let me multiply 16 by 50. 16 multiplied by 50, I'm going to be having 800. So if I type in 800 now, then I'll offset this by 800. Let me do this way. Offset 30. Take this by 200. Okay, let me delete this. So this is here. So let me measure this from here now to this place. To overlap 600, no, I want this to be 800 DLI. So I will set 800. So this is coming this way, and I'll do my 200 backward. DLI. I measure this. Alright, so this is actually in a case where you have a reinforcement that actually breaks at the bottom here. Okay, so if you have that, you are going to be having an overlap in this way. So this is actually how your beam detailing is supposed to look like. Okay, so let's look from our beam detailing that we have gotten from let's say from Prota structure here. So you can see here we have an overlap here. We also have another overlap here. Okay, we have an overlap here, we also have an overlap here. Okay, so by the time you calculate this now, this plus this plus this plus this plus this is actually should be exceeding, including the bends that you are actually going to be having. This has actually even exceed let's see, 4673 plus 3433 plus 2516 plus, okay, that is 2518 rather, plus 422 plus 322 plus 3302. So we are having 18 point something, which is even more than the 12 meters, aside from all these bends that are actually not even really included, okay, in it. All right, so that is that. Your design will definitely tell you whatever that you should use. Okay, so we have been using assumed values all through to actually achieve this detailing. We just use an assumed value. So in a case like this where you have a reinforcement here overlapping with another one that is coming this way, in that case you may need to have this reinforcement. Now we are going to be having 4 different type of reinforcement. This reinforcement based on its shape and its length. All the size of reinforcement are the same, but the length of this reinforcement is different from the length of this reinforcement. The length of this reinforcement is also different from this length of this reinforcement. So definitely it's going to be having a different name. So it depends on what the shape, the length, and then the diameter of that reinforcement. So this is 3, this is O1, this is O2, this is O3, this is definitely going to be O4. So we have 4 different reinforcements in this particular beam. Sorry, I need to change this to 4. So that is exactly how to actually come about your beam detailing in AutoCAD, or your beam detailing where you want to do it manually. It mustn't be AutoCAD. You may want to do the sketch manually on a sheet of paper. Probably maybe you are on site and all of that. Okay, so that is actually how to achieve your detailing manually. Okay, and then the next thing now is to get the cross section of this particular beam. To get this cross section, all I need to do is just to pick the cross section symbol, which is this. Let's say I want to get the cross section of this, for example. Now you can see this is cross section. Because this is our first cross section, let's assume that this is our first beam in this particular design. And then let's say this is the first cross section, is going to be cross section 1 In that case, now to get the cross section of this particular beam, you can see here at the top here we have 3y16. Here at the bottom here we have 2y16, for example, that our design has given us. And then this beam, if you can remember, I said by highlighting this beam here on this particular general slab and beam layout, you are going to see that around this area here we are having a T shape. Around here we are also having another T shape. So this is actually a T-beam. So in that case, now our cross section is supposed to come in form of a T. So this is a T shape. So all I need to do is just to pick this T shape. Let's say I pick this now, and then let me check, or let me design this manually for you, just in the shape of your T. The first thing here you measure is 150, which is the thickness of the slab, and then you pick a line, and then we have 230 as the size of my column, 230, which is the size of this beam, sorry. Then the entire height of this particular beam is 450 mm. So if I use the fillet, okay, okay, but you know this slab here now is actually going to be this showing that we have the slab and the beam together, attached to each other, okay. And then it's going to definitely be continuous, because you cannot show the entire length of the slab in one particular beam. It's not possible. So we are going to show it that this is actually continuous, okay. So if I try to make a continuous sign here, so here now I'm going to have this this way, and then all I need to do is just to get a continuous sign here, showing that this is actually continuous. Sometimes getting this continuity sign is it's a big challenge for me sometimes. How am I doing this? Okay, sorry. Right, then this will come this way. So if I mirror this, alright, so I have this continuity here showing, and then this beam here, okay, the thickness of my cover for this beam, let's say, is 25 mm, okay, 25. So if I take, so I'm going to have it this way. So I'm going to have you this way. So the next thing I need to do is to use a donut. Specify the thickness of this donut. I don't think I'm doing. Okay, let me just use the scale here to make it smaller. Sorry, let me take this donut again. Alright, specify inside diameter of donut. Specify outside diameter of donut. 30. Okay, let me just leave it. Aha, good, it's hashed. Alright. So here now on this cross section I have 2y16, here I have 3y16. So this is definitely going to be in this form, okay? Alright, this is actually how this is going to look like on that particular cross section. All I need to do is just to type in what cross section is that. This is section, text edit, this is section 1.1.1.1. So that is that. You can just take the measurement here for this. This is 150. The entire length, entire height is 450. The breadth of this is 230. So that is done. And then what else? Then the names of this reinforcement, you can just give it a name based on what you have here. So this is reinforcement 1, this is reinforcement 3. So I have 111. All I need to do is just to type in 111 for this. So I'll just text edit this text and name it 1. This is 1, this is 1, and this is 1. And then the one bottom here is 3.3. So I'll just text edit this and name it 3, and then I copy this and I also name it 3. So this is actually how to come about the cross section of this. And then you know, this is this hang here, or called hook rather. You will also get that from your BS 800. Okay, so there is a formula for that. I think that should be 9D, the diameter multiplied by 9. Yeah, so it is actually, the hook length is always, I think, 9 multiplied by D. If I multiply 9 times the thickness of this reinforcement is 10, because our links is Y10, so that will be 90. So you just do your links by 90. Let me measure with dimension angular. So 90, which is almost around 90. So if I extend this a bit, I'm going to have 90. So all you need to do is just to lay your hands on it to be able to have a better insight of how to come about your bends. Okay, the shape, there is this shape codes. Just lay your hands on them. Each of your bends, okay, there are codes, there are standards to each of these bends. Okay, and then this is not a polyline, or like all you need to do, like you were asking me a question on how to, if there is a standard to the thickness of your reinforcements, and I don't think there is any standard to any thickness of any reinforcement. All you need to do is just to try as much as possible to make your detailing presentable and readable, that whoever is going through your detailing can be able to differentiate the lines that is representing your links, the lines that is representing your both your main bars. Okay, it's just lines. Okay, so you must know how to differentiate them to make your detailing much more easy to actually read, okay, or easy to interpret. So I believe if you have any other questions as regards to how to come about this, you can just let me know, and then we'll trash that all together. But this is basically how to come about your detailing manually on AutoCAD, or you want to do the drafting manually on a sheet of paper with a pencil or a biro or whatever tool you want to use to achieve your detailing. But this is just the concept, this is just the insight on how all of this is actually being done. Okay.